Screencast 18.3 Energy and Nuclear Fusion. How can you take a look at energy without considering this very exciting form of energy, nuclear fusion, something that's been, what is the saying? Always 20 years away. Well, here's a little schematic of what a inertial confinement system looks like. You take a tiny amount of hydrogen, or one of its isotopes, heat it up to several million degrees Celsius, and that's the hard part, and maintain it as a near perfect sphere. You pull that off, more energy should come out than went in, as it fuses to form helium. That generates enormous amounts of heat, and then a nice old-fashioned heat transfer system, literally like maybe pump some water through there and let it get heated up like crazy, will allow for heat exchange and a turbine and the generation of electricity on a constant basis. Well, that's the idea. And in 2012, the director of the National Ignition Facility, that large building in California that we pay for out of our tax dollars, it was said that we're now in a position to say with some confidence that ignition, meaning break even in terms of heat, will happen in the next 6 to 18 months. Wow, that's a big deal. However, and in fact, on October 7th, 2013, it was published that more energy went out than went in an experimental system. However, their latest statement as of, in this case, at this recording, within the last week, at this point, we know that to reach ignition, they need to really double the pressure at the very center of the fusion reaction. They are no longer as optimistic as they were here, although technically they achieved their goal. In order to get a sustainable fusion reaction going, the NIF has a lot of work to do. And be aware, this is one of many research projects going on worldwide. For this class, I would like each of you to read 2 articles. One, a fairly non-scientific article about fusion power and whether it is the holy grail, the answer to all our problems, and a far more scientific analysis by a paper from the Fusion Science and Technology. I guess you can see what their angle might be, from 2004. Trying to discuss fusion and comparing it to other systems. This, to me, is a really fascinating article. And if you're going out into the world to be a scientist and hopefully make the world a better place, you really want to be thinking about energy and how it's been such a difficult thing for us to deal with in terms of the side effects, sometimes catastrophic side effects to the planet. In any event, read these articles, please. Be prepared to provide a research-based response in support or to refute these articles. Anything that you say should be based on your own research and supported in some way. Okay, this is Screencast 18.3, Energy and Nuclear Fusion.